Assalamu alaikum, brothers and sisters. Welcome to the Journey of Quest, where we quench your thirst of knowledge. Ever wondered why it's warm in one place and cold in another? Or maybe why certain regions receive heavy rainfall and others remain parched? The intricate answers to these fascinating questions lie in comprehending the broader circulation of our planet's atmosphere and ocean, two major driving forces behind our planet's climate. Let's initiate this exploration with the first component, the atmosphere. Picture it as an immense, boundless sea of air, persistently in motion, swirling and dancing to the rhythm of thermal energy. This ceaseless movement of the atmosphere, known as atmospheric circulation, is a result of the sun's radiant heat, which doesn't distribute evenly across the Earth's surface. Delving further, the Earth's equatorial region, being closer to the sun, receives a greater concentration of heat. This causes the surrounding air to warm up, expand in volume, and gradually ascend, creating a region of low atmospheric pressure. Simultaneously, Earth's polar regions, located at greater distances from the sun, receive substantially less sunlight. Consequently, the air in these regions remains considerably cooler and denser. This denser air, being heavier, tends to sink towards the Earth's surface, thereby creating a region of high atmospheric pressure. These contrasting pressure conditions at the equator and poles establish and maintain a global wind pattern, which we refer to as atmospheric circulation. This dynamic circulation plays a crucial role in distributing heat and moisture across the planet, thus shaping local and global climates. Deeper within this atmospheric circulation, we find three distinct cells in each hemisphere: the Hadley cell, the Ferrel cell, and the polar cell. These cells represent the Earth's primary wind patterns and are key to understanding our planet's climate. The warm air rising at the equator travels towards the poles, gradually cooling down. Around 30 degrees latitude, this air cools enough to sink back towards the Earth's surface. This process forms the Hadley cell, a consistent pattern of atmospheric circulation found around the equator. Positioned between 30 and 60 degrees latitude, we have the Ferrel cell. This cell's characteristics include surface winds blowing predominantly towards the poles, driven by the atmospheric pressure differences between the equator and the poles. Finally, at latitudes above 60 degrees, we find the polar cell. This cell is marked by cold, dense air sinking at the poles and moving toward the equator. The polar cell, found at latitudes above 60 degrees, features cold air sinking at the poles and moving towards the equator. Now let's turn our attention to the ocean. Oceans, which cover about 71% of Earth's surface, play a crucial role in maintaining the planet's overall climate and weather patterns. The circulation of the ocean is a complex system that is driven by various factors, including wind, tides, and differences in water density. This density is largely affected by temperature, a process known as thermohaline circulation. Surface ocean currents, a significant part of this circulation, are primarily driven by wind. They follow specific patterns that are influenced by the rotation and shape of the Earth. These intricate patterns have immense implications on global climate and weather patterns, as well as marine distribution. Surface currents transport warm water from the equator towards the poles. This movement of warm water has an immense impact on the climate of coastal regions, making them more temperate. Simultaneously, these currents carry cold water from the poles back the equator. This movement helps in moderating the tropical temperatures, making these regions habitable. Beneath the surface, another fascinating process begins, the thermohaline circulation. As water cools at the poles, it becomes denser and begins to sink. This process creates a deep water current that plays a crucial role in the overall ocean circulation. This colder, denser water then travels towards the equator. Here, due to the warmer temperatures, it gradually warms and rises back to the surface, completing a remarkable cycle that impacts not only the ocean, but the entire planet. The combination of atmospheric and oceanic circulation plays a significant role in distributing heat around our planet, influencing our climate and weather patterns. This incredible process is like the Earth's own central heating system, a complex and ever-changing ballet of winds, currents, and temperature shifts. It is responsible for creating the diverse range of climates we see on our planet, from the sweltering heat of the tropics to the biting cold of the poles, and the pleasant, moderate temperatures we experience in the middle latitudes. Each element intricately connected, each one dependent on the other in this grand climatic symphony. It's the reason why the tropics are warm, the poles are, and the middle latitudes have a temperate climate. The tropics are warmed by the sun's powerful direct rays, which leads to a rise in temperature and the creation of low pressure. Meanwhile, the poles are kept cold due to the Earth's tilt and its rotation on its axis, which results in these areas receiving less sunlight and therefore less heat. The middle latitudes, in turn, enjoy a more balanced climate due to the continuous exchange of heat between the tropics and poles. As warm air rises at the equator, it moves towards the poles, cooling down on its journey and sinking as it reaches the colder zones, only to be pulled back again to the equator, forming a continuous cycle. But it's not just about temperature distribution. This circulation also helps distribute nutrients in the providing a vital lifeline for marine life. Nutrients from the deep ocean are brought to the surface by the upwelling of water, supporting the growth of phytoplankton, the base of the oceanic food chain. To summarize, the general circulation of the atmosphere and ocean is a complex system that helps distribute heat around the Earth. The atmospheric circulation is driven by in-solar radiation, creating three distinct wind cells: the Hadley, Ferrel, and polar cells, each playing a significant role in global climate patterns. On the other hand, ocean circulation is influenced by multiple factors. It is primarily affected by wind, tides, and differences in water density, which interact in a complex manner to cause surface currents and deep water currents. The study of these processes is indispensable for predicting weather patterns, understanding climate change, and mapping the distribution of marine life. So, the next time you wonder why your location has a particular climate, you'll know it's all down to the intricate ballet of the atmosphere and ocean. Thanks for watching us share our videos, subscribe our YouTube channel, and press the bell icon and stay curious for new uploads.